Hi class. In this video, we're going to be talking about how to compare and calculate probability. Probability is the likelihood or chance of an event occurring. Probability can be calculated by taking the favorable outcomes and dividing it by the total possible outcomes. Probability can be expressed as a ratio, a fraction, a percent, or a decimal. Now, an outcome is just one possible result of a probability experiment, and a favorable outcome is a successful result in a probability experiment. Now, the word successful can be subjective. So think of favorable outcome as the outcome that you would like. Now, note a probability that equals to 1 has a 100% chance of occurring. So that means the event, if it equals to 1, it will always occur. Now, comparing probability can be compared obviously with fractions, decimals, and percent, or a ratio. In this case, we're just going to focus on fractions, decimals, and percent. As your fractions, decimals, and percent get closer to 1 or 100% for the case of percents, you are having a higher chance of occurring. So larger fractions, decimals, and percents will have a higher probability or chance of occurring. So let's go over an example. Here I have a coin that has a 50% chance of landing on heads. Now, a coin has two sides, a regular coin. So the two sides would be heads or it would be tails. So 50% chance, a half, that would make sense. Now, a normal dice normally has six sides. So a dice has a 1/6 chance of rolling the number 2. On a six-sided dice, I have the numbers 1, 2, 3, 4, 5, and 6. So 1 out of 6 chance of rolling on the number 2 would make sense. Now, which has a higher probability? To compare them, we can either change both of these to a percent, change both of them to a decimal, or change both of them to a fraction, and the higher value would have the higher probability. Since my coin is already as a percent, and I feel like percents are pretty straightforward to compare, I'm just going to keep it as a percent and change the dice here into a percent, the fraction for the chance of the dice. So 50%, that's fine. 1/6 is going to be equal to, if I convert it to a percent, 16.6 repeating percent. So since 50% is higher than 16.6 repeating percent, I can say the probability of flipping a coin and landing on heads is higher than rolling a dice and landing on the number 2. Okay, now let's talk about calculating probability. So here's my first example. What is the probability of the spinner here landing on A? So A is the region represented with this green space here. And I want to express my probability as a fraction, a decimal, and a percent. So first things first, I want to talk about something. So P bracket A, this basically means the probability of A occurring. So A is just what I'm looking for right now. So again, probability bracket A bracket just means the probability of A occurring. Okay, great. So now, recall how to find the probability of A. We need to take my favorable outcomes and divide it by my total possible outcomes. So right now, my favorable outcome is the outcome that I would want or like. In this case, it would be to land on A. So there's only one region that is A here. So my favorable outcomes is just 1. Now my total possible outcomes, on this spinner, there's actually 5 outcomes. I could land on A, T, E, S, or K. So hence my total possible outcomes is, well, 5. So as a fraction, my answer would be 1 over 5. Now as a decimal, 1 over 5 is going to be 0.2. So as a decimal, my answer is going to be 0.2. And now as a percent, I have to convert 0.2 to a percent. My answer should be 20%. So hence, this is going to be my answer right here. The probability of the spinner landing on A is 1/5, 0.2, or 20% when we express it as a fraction, decimal, and percent. Okay, now let's go over this next example. A bag contains 10 marbles. I want to show the probability of the following events as a fraction, a ratio, and a percent. So the ratio is a bit new now. Now for A, I want to select a red marble. So I need to do the thing I did before. Probability is defined as the favorable outcomes divided by the total possible outcomes. So for the probability of selecting red, I'll let R be red. My favorable outcomes is going to be the red marbles. So in the bag, I have 1, 2, 3, 4, 5, 6 red marbles, as you can see in this picture over here. So I'm going to write 6 for number of red marbles. Now it says the bag contains 10 marbles in totals. That's my total possible outcome. So hence 6 over 10 is going to be my answer here for the as a fraction, right? So this is my answer as a fraction for the chance of selecting a red marble out of the bag. Now I can also simplify this by dividing both the top and bottom by 2. If I do that, I'm going to get the answer to be 3 over 5. So 3 over 5 is my simplified fraction. Now, after that, I want to find the ratio. So the ratio could just be 3 colon 5. So that's my ratio right there. And now my percent, 3 over 5, is just going to be 60%. So my answer here is going to be 3 over 5, 3 colon 5 if it's a ratio, or 60% when expressed as a percent. So that's for A. Okay, now for B, it says to select a red marble or a blue marble or a green marble. Okay, so if I'm selecting either a red or blue or green marble, that basically means I'm at 100% pretty much, right? Because if I take red, I have 6 reds, I have 3 blues, and then I have 1 green. If I add those all together, I'm going to get, so here, probability of selecting red or blue or green is going to be 10 out of 10, right? 10 out of 10 because I have 10 marbles in the bag and I just selected all of my colors. So my probability is just going to be 10 out of 10, or you can just call this 1 out of 1 as a fraction. And then as a ratio, you can call it 1 colon 1. And as a percent, you can just call it 100%. So that's my answer for B here. And I guess you can also simplify 1 out of 1 to be just 1, right? That's one way to make it even more simple. So, or just 1. Okay, now for C. The probability of not selecting a red marble. So not selecting a red marble. So the probability of not red, so not R. So the probability of not selecting red. Well, how many marbles are not red? I got 3 blues and 1 green. So technically speaking, 4 marbles are not red, and I got a total of 10 marbles. So my probability should just be, as a fraction, 4 over 10. But if I divide both top and bottom by 2, I'm going to get 2 over 5. So 2 over 5 is going to be the probability as a fraction of not selecting red in the bag. And as a ratio, that's going to be 2 colon 5. And as a percent, that's going to be 40%. So I have a 40% chance of not selecting red. Now, notice something here. 60% is my probability of selecting red, but 40% is my probability of not selecting red. Notice 60 plus 40 is 100%. So I have a 100% chance of either selecting red or not selecting red, because not selecting red means I get blue and green. And we already know if I can take any of those colors, I basically have a 100% chance of reaching into the marble bag and getting any of those colors.